today is for similar triangles. Okay, we can have all different similar shape. We can have different similar shape for rectangle, similar trapezium, like any similar hexagon. I can have everything. But like today we focus on triangles. Same as a congruent triangle. We have different rules to prove they are congruent triangles. So what I want to do is to make a table here. Okay, is to make a table here. Draw a table like this. Okay, so I'll do a table like this. Okay, we have two columns. We have one column for congruent and one column for similar. Okay, let's do a little bit revision on what can, well, you know we have 3 angles and 3 sides. Okay, so 3 lengths, 3 angles, 16 in a triangle. Okay, 16 in a triangle. So for congruent triangle, can you tell me what's one of that? What can prove it's a congruent triangle? What can prove that's a congruent triangle? Anything? 4, there are 4. SSS, that's one of that. Good. SAS. SAS, okay, A must be in the middle, correct? AAS, or what else can I say? AAS? Similar, like AAS, ASA, or like the S can be anywhere, okay? ASA or AAS. Also, I have explained there. I said if it's AAS or ASA, you have 2 angles given, but it's actually, you know that 3 angles must be the same. I can say it's an AAAS case. Well, I can say that's an AAAS case. Because if you know 2 angles are the same, the 3rd angle must be same as well. But even though you know 3 angles are the same, you can't prove it's a congruent triangle. For congruent triangle, you must have the side involved. Okay, at least one side involved. So 3 angle cannot prove it's congruent. Okay, what's the last one? RHL or HL or HS, that's all good. RHL, I can say that's a RHL. It's a right angle triangle and hypotenuse and one side are the same. Okay. Now, for congruent, you need what? You need angle equal and side equal. Okay, the side must be the same as well. So the S means the side equal. The A means the angle equal. Okay. What now I want to say for the similar? Okay, what's similar? Similar triangles need to satisfy all the 3 angles are the same and all the sides needs to have the same ratio. So now my similar triangle, I have angle must be the same. Again, like all the angles must be the same. That's the same as congruent triangle. But for the side, for the S, it represents the side is the side is in same ratio. Okay, the side is not the same, but instead the side must be in the same ratio. Okay, the side must be in the same ratio. Okay, so what we will have for similar, we have SSS for congruent, right? We will have SSS for similar as well. But the SSS doesn't mean the sides are equal. That means that all the three sides are in the same ratio. Okay, so it doesn't mean side equal. The SSS in similar means the sides are all in the same ratio. Okay, or the sides are all in the same ratio. Okay, similarly, we have SAS as well. SAS means there are two sides with the same ratio and the included angle is equal. Okay, included angle is equal. So give your example. We have 2 here, 1 here, and tells you that's 30 degrees. I have 4 here, 2 here. This angle is 30 degrees. Then I can say those two triangles are similar because we have two sides with the same ratio and the angle included is the same. Okay, the angle included is the same. Okay, the ODS doesn't mean equal now. It means in the same ratio. And the angle means equal. Okay, the angle means equal. Okay, for the third one we have AAAS or say AAS or ASA. So two angles and one side. Okay, two angles and one side. We know 4 pieces of information to make it congruent. 3 angles equal and any corresponding side to be equal. Okay, it's easier in similar triangles. What we need AAA. If we know 3 angles are the same, then it must be a similar triangle. I don't need any information for side, for similar, okay? I don't need any information for side. If I know 3 angles are same, like 45, 60, and 75, then if we have another angle with those 3 angles, they are similar triangles. They must be similar triangles. This one is quite unique for triangles. Because it's not enough for trapezium, for example. It's not enough for trapezium if they just have all the angles to be the same. They need information for side as well. Remember the example I gave you yesterday? I said this trapezium and this trapezium cannot be similar, even though they have all the angles to be the same. Okay, even though I know all the angles the same already, I still can't say they are similar trapeziums. But for triangle, it's easier and it's special. So if I know 3 angles of the triangle are the same, then we know they are similar shapes. Okay, that's AAA. Okay, last one we have is RHL as well. So we have right angle triangle, and if the hypotenuse and one of the sides are with the same ratio, then they are similar triangles. So for example, this one. Okay, for example, this one. I know that right angle triangle, that's the first piece of information. The second piece of information is the hypotenuse and the side with the same ratio. They are with a ratio of 2. Then they are similar triangles. Okay, then they are similar triangles. This is not the SAS case, because if it's the SAS case, I need this A. Okay, I need this A, but we have the right angle, like the 90 degrees. So it's not the angle included in the 2 sides. So that's why we call that a special one. It's called the RHS case. Okay, it's the RHS case. Okay, so after I give you this table, it's very easy. Okay, because if you remember the congruent, then you can remember the similarity as well. They are exactly the same thing. See, we have SSS, we also have SSS. We have SAS, we still have SAS. We have RHL, we have RHL. And this one is just a little bit different, and it's getting easier. We don't need information for side, we just need information for angles. So AAA here. Okay, after we know that, let's have a look at this one. Okay, have a look. Do you think they are similar triangles? Do you think they are similar triangles? Okay, can we find corresponding side? Okay, what's the corresponding side with AB? DE, right? What's the corresponding side for AC? DF. What's the corresponding side? Well, the other pair must be the corresponding side. This one and this one. Okay, what I like to do is I like to label the angle with different colors. Okay, I like to label the angle with different colors. Okay, so see the red and the blue one? I will make a dot here, like with this color, and I can make the green and the red one with this color, and then the other empty one must be the last pair. So how I can prove they are similar triangles? I need to show one of the evidence. Okay, it's either AAA or SAS or SSS or RHL. I need to show one of the evidence. You know, each evidence got 3 components, like SSS, there are 3 things, or SAS. So what I will do, this is obviously SSS case, there's no angle at all. So how I can write it is AB over DE, that equals to 28 over 7, that equals to 4. And BC over EF, that is 16 over 4, that equals to 4. And then AC over DF, that is 32 over 8, that is 4. I need 3 components. Okay, I need to list them out. Like, what's the first S, what's the second S, what's the third S. After I write that, I can make the conclusion AB over DE equals to BC over EF, because they all equals to 4. So equals to AC over DF, SSS. So, okay, after I said why they are similar, because it's SSS, I have shown that, clearly state that. So I will show, so therefore, okay, triangle ABC is similar to triangle. Okay, why I make the color dots? Okay, ABC, right? A is that, so D, E, F, according to the color, okay? A is the light blue one, so I will say D. And B is the circle, I will say E. So D, E, F. Okay, so that's how I can write this. That's why I make different colors. I see the different color, I can write that in order. Okay, let's have a look at the next one. This one has no information at all for side. Okay, there's no information for side. So definitely AAA case. But I want to label that with the correct color. So this blue one is just the same, is the shear angle in both triangles. And I can make this one a tick and this one a tick. Okay, when you describe the angles are equal, you need to describe them in corresponding pairs and use the letter within that triangle. For example, if you want to describe the angle C equals to angle C, what you will do is, well, I use the small triangle first, is the angle BCD, okay? BCD is this angle, equals to one angle in the big triangle. So you need to use ACE. So that equals to ECA. Okay, in corresponding pairs, because can you see BCD, B is this cross. So you will use the E as the corresponding point. So it's ECA. It's the same angle, but you use the letter for the triangle you want to talk about. BCD and ECA is the same thing, but I want to use 2 different letters to distinguish between that's the 2 triangles. So now I'm talking about the first small one. Okay, the next one is the cross. Okay, the cross. So CBD equals to the angle. Okay, B is same as E. So CEA. Okay, so this triangle is the same as this angle is the same as this angle. So CBD is CEA. They are the same. Now the last pair will be this one here. So the angle BDC equals to EAC. Okay, so due to AAA, so triangle BCD is similar to triangle. Okay, so BCD, I use B, C, and D. So is E, C, and A. Okay, B is this blue one, so E. C is the same point, so E, C, A. Okay, must write in the corresponding point. Alright, the next one. Which rule we should use for this one? Side, angle, side. So we can talk about the side first. Okay, definitely this one is the pair of this one, and then this one is the pair of that one. So I can give a angle here, that's the correct angle, and that is the angle, corresponding angles. So what I will say is AB over DE equals to 1 over 2. BC over EF, that equals to 3 over 6 and equals to 1 over 2. So I want to make the conclusion AB over DE equals to BC over EF. You cannot directly write this one. Okay, you cannot directly write that because why? Why this equals to that? Okay, the reason I have shown above. Okay, that equals to half, that equals to half, that's why they are equal. You can't directly say they are equal. You need to show some evidence, okay? Some simple evidence. And also, the angle ABC is same as the angle DEF equals to 120 degrees, which is a given information. So due to SAS, triangle ABC is similar to triangle DEF. Okay, last one. Well, first of all, RHS, you still have 3 pieces of information, R, H, and S, or L. So you will say triangle ABC and triangle, I can say triangle ABC and triangle, okay, so A is this one, this one is the pair with it, B is that one, that's the pair with it. So the point, we have this one and this one. Okay, so triangle ABC is the, okay, can you see A is the angle with no color? So with no color is the same as this one. So So it should start with F, E, D. Okay, can you see it's not DEF, it's FED because the point, okay, because of the point. So I start with A. A is the with no color angle, and this will be your starting point. So it's F. B is the right angle triangle, so it's FED. R, right angle triangle. Okay, this is the R. Okay, it's the right angle triangle. Also, AC over DF equals to 5 over 10, which is a half. That's the H, the hypotenuse. This sentence means the R, which is the right angle triangle. And then BC over DE, that equals to 4 on 8. That is half. That's the side. Or say the length. So AC over DF equals to BC over DE. That equals to half. So triangle ABC, well, RHL. So triangle ABC is similar to triangle FED. Okay, I've shown 4 different examples why they are similar and how you need to show the proof. Okay, you need to show the proof clearly by this method. Have a think about the congruent triangle. Congruent triangle is not enough to only use angle. There must be a side involved. But for similar triangle, there's less requirement. I can have no angles, only use side, 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 or I can have no side at all, like only have angle, angle, angle. So similar triangles is actually a bit easier compared to congruent triangle. There's less restrictions here. Okay, if we can go to next page. Have a look at example 2. Okay, see this shape. Okay, if I give letter A, B, C, D, E, like this. Okay, give a letter A, B, C, D, E. Do you think triangle ABC is similar to triangle ADE? Yes or no? ABC and ADE, are they similar? Yes? Yes? Why? Which one? Angle, angle, angle. Okay. If you want to use side angle side or like side angle side or RHS, you must have 2 given pairs of lengths. Well, you also say the ratio are the same. If you don't have 2 pair, how you can say the ratio is the same? There's no ratio. You can only find 1 ratio, but how about the other one? You don't know. So if you talk about side, there at least needs to be 2 pairs of side given, and you compare them. So this case is you don't have 2 pair. You only have 1 pair. So what you can do is AAA. Most of the similar triangles are proved by AAA. It's very hard to have 2 pairs of side and then say they are similar. So most of the time, 90% of time, you use AAA to prove they are similar triangles. So in this case, it is AAA case because angle A is the same as angle A. This angle here is the same as this angle here, and the other 2 right angle here. So what I will say is triangle ABC is similar to triangle ADE due to AAA. There will be questions in your test asking about why those 2 triangles are similar, which one of the rule make it satisfy, like is AAA or SAS or SSS, you need to clearly state that. So in this case, it's AAA make those two triangles to be similar. Okay, but why we want to know two triangles are similar? Because after you know two triangles are similar, you know all the corresponding pairs will have same ratio and all the corresponding angles must be equal. Why do you want to prove they are similar? Because you want to use the property after that. Okay, all the angles are the same, all the lengths are in the same ratio. So in this case, after you know they are similar triangles, okay, so I will re-sketch those two. So this is the ADE triangle, and this is the ABC triangle. So what you know is AC equals to X, and AE equals to 6.6. And you also know that this is 3.6, and that is 1.2. And that's right angle triangle. Okay, I just put the small one outside. So what I can say, because those two triangles are similar, therefore BC over DE must be the same as AC over AE. Okay? You have three numbers and one X. I want to set up them together so in the same ratio. So what I have is 1.2 over 3.6. That is equals to X over 6.6. Just sub the numbers in. And I have a third equals to X over 6.6. And X equals to a third times 6.6. X is 2.2. Yes?
Did you also do X over 1.2 equals 6.6?
Sorry, again? X?
X over 1.2.
Yep.
Equals 6.6.
It will give you the same answer, but it's not the same logic. Like, it's correct. It's just rearrange the formula. Like, you basically rearrange this one. It's still correct, but like, if you use the property for similar triangles, it's that corresponding pairs are in the same ratio. So you better write them in corresponding pair ratios. This is still, I can explain it, like, but it's not through similar triangles. It's through another logic. Yeah, that's correct, but better not to use this. Okay, you write corresponding pairs in vertical and then equals to another corresponding pairs. Okay? Do we have any questions for this one, like, or what we have done so far? Yes?
Do we have to state why it's AAA, or can we just go straight on?
Okay, so what I like to do is I always prove it, like, because this angle equals to that, this angle equals to that, this like three pairs, and then I said that's AAA. That's what I teach last 2 year students to do. And also if you have SAS, you need to prove it as well before you said that's a similar triangle. That's the most proper way to do it. But as you might know, for VC exams, they don't do proof questions and they don't do geometry a lot. They're not focusing on that at all. Like for very basic, you still need to use similar triangle, but for very basic level of similar triangles. And I see all the marking scheme, they're not really proving it before they use it. They just kind of assume, well, the most common shape they use is this one. Like in 3-dimension thing is this shape. So they already assume you know that's a similar triangle, and most of the questions is directly use of that. So that's why I'm not really strict on this one this year. Last year I asked the students to show a proper proof for everything from the beginning and then ratios and then whatever equals to. But I see all the marking scheme has been made is not proving it at all. So this year I'm not making that strict, but it is correct. Most correct way should be show everything first and then state why they are AA and why they are similar. Okay? But like if you can recognize it, that's fine. Okay. Let's have a look at the next question here. Well, I will label this as A, B, C, D, and O in the middle. Okay. Again, there's 24, 12, B, 5, A, and 8. I want to work out A and B values. Now, I want to ask you, which two triangles you will use to find? Michelle?
A or B and D or C.
A, O, B, and D, O, C, correct? If I said triangle A, O, B is similar to triangle, what's the order you will give me? C, O, D, correct. Okay, why they are similar? A, S, S. It can't be side.
Side angles. Alternate angles. I mean, vertically.
Yeah, alternate angles, vertical angles. So what's the reason? For
Side angle. Side angle.
angle. There's no side. There's only one pair of side already given, which is the 24 and 8. But you can't use one pair of side. You need at least two pairs of side to say side. You don't have a single side. You don't have AAS. You need to say at least two pairs. So basically it's 4 given numbers. Okay, you need 4 given numbers. So you only have, you have 1, 2, 3, 4. But those 4 is not the same pair. The 12 and the 5 is not the same pair, so you can't use that. So what we use is they are parallel lines. A, B, and C, D, they are parallel lines. Okay, if I told you last year, I would say, show why the angles are equal. I will ask you to write, because AB is parallel to CD, therefore, this angle is the same as this angle. And this angle is same as this angle because they are alternate angles, and the angle O and O, they are the same because they are vertical opposite angles. Okay, I will ask you to show why those 3 angles are equal, and then therefore because of AAA, they are similar triangles. There's quite a lot to write actually if you want to do a proper proof. But in this case, I'm not really strict on that. Okay, let's see the side. I'll use this color. Let's say OA first. Well, you know that AB will be corresponding to this one, right? AB and DC, that a pair. AB and DC, that a pair. Okay. OA. Look at OA. I'll write OB first. OB. Who is the corresponding side with OB? OD, like this one. Okay, this one. So they are actually the corresponding pair. Why they are the corresponding pair? Because they are opposite to the same angle. Okay, the lengths are opposite to the same angle. So COB is opposite to this pink angle here, and then OD is opposite to this pink angle as well. So they are a pair. And therefore OA and OC, they are the other pair. Okay, OA and OC, they are the pair. So you will say, because they are similar triangles, therefore OA over OC, okay, the top one needs, all the lengths needs to come from a same triangle. So it equals to that, and it also equals to that. So OA, I use the top triangle. So what I should have is OB, and I should have AB, everything from the top triangle. Then the bottom, OB, corresponding pair is OD. AB, corresponding pair is CD. So they are in the same ratio. Because they're similar, therefore, those lengths must be in the same ratio. So, OA is 12. OC is A. OB is B. OD is 5. AB is 24 and CD is 8. Which equals to 3, because 24 over 8, that is 3. So the length ratio is actually 3, the top one compared to the bottom one. So your 12 over A needs to be 3, and your B over 5 needs to be 3. Okay, so they're all equals to 3. So A equals to 4 and B equals to 15 in this case. This question is actually appear in what last year or the last 2 years test. So this shape is very commonly used. Okay, this shape is very commonly used. So just be careful with this question here. It's a very good question to see which are the corresponding pairs. A lot of students do OA and OD as a pair and OB and OC as a pair. That's a lot of common, it's a common mistake. Most of the students do the same thing, OD over OA and then OB over OC, but they are not actually a pair. You need to recognize who are the corresponding pairs. Okay, that's important. Okay, have a look at example 3. Okay, this is the similar triangle in 3-dimension shape. So a core has radius 2 centimeters and a height of 4 centimeters. So it's given 2 here and 4 here. And the top of the core cut horizontally through a point D. So I cut a small core from the top. Okay, I remove a small core from the top. Where AD equals to 1, I want to find the radius of DE. Okay, let's make this bigger. What I have is the length of this pink. This is 1. I want to know this. Okay, this shape used a lot in VC exam. I feel that's the only shape they have in VC exam. Because they use or cylinder. I think the other one is a cylinder. So this one, because you can see similar triangles here. Can you see 2 similar triangles here? Yeah, which 2? Yeah, AD and ABC. That's the only thing you can see from the core. So why they are similar? Why they are similar then? Angle again. Okay, angle again. Again, I can't say that. So what I should say is triangle ADE is similar to triangle ABC. Because of AAA. Okay, it's the same shape as this one. It's actually exactly the same shape as this one. It's just rotate 90 degrees. Okay, rotate 90 degrees. Then what we have is, because they are similar, so we have AD over AB equals to DE over BC. A lot of students is not confident to see the 2 triangles put together, like they are in the same big triangle. If you feel uncomfortable with that, just move the small one out. Draw a separate one, draw a separate small one, a separate big one, and label all the sides given. So basically I have ADE like this, and I have ABC, which is the big one here. And those 2 are similar. AD equals to 1. I'm asking for what is DE, and I know AB is 4 and BC is 2. That's all we have. So 1 over 4 equals to DE over BC is 2. So DE equals to a quarter times 2, and DE is a half. Okay, DE equals to a half. Alright, that's the end of what we will test for. So exercise A to exercise E. Similar triangles, congruent triangles, definitely very, very important. What I want you to do for the rest of 5 minutes, go back to the page we did yesterday, and example 2 is a similar triangle questions, trying to figure that out. Okay, page 6, example 2, trying to figure that out.